Hello and welcome back to my Satisfactory guide. Late game production can be incredibly powerful. What's the easiest way to overcome it? Go green. Uranium green, that is. You need nuclear plants. Setting up a nuclear plant can seem daunting at first, but just hear me out. It's worth it. You just need to follow this easy multi-phase plan, and switching over to nuclear power will feel like a breeze, and it will save you a lot of time in the long run. That's right, no more upscaling power every 30 minutes. Believe me, I've been there and it's not fun at all. So here's how it works. Nuclear plants burn one of three fuel types: uranium, plutonium and FICSONIUM, and they are increasingly difficult to produce, and excluding the last tier, they generate unsinkable waste after burning. That begs the question, what do you do with the waste? Well, you have two options. One, you stack them in a massive radioactive pile in containers until the end of times, or two, you use it to make the next tier of fuel until you reach the much cleaner FICSONIUM. Now let's talk about setup. We want to immediately benefit from the power plant, so in the first stage we'll be focusing on burning just uranium rods. The setup to make them is quite simple actually. You only need a blender making encased uranium cells and a manufacturer making the fuel rods. And what I do is underclock the blender to 80% and use a 1:1 ratio. This setup produces 0.4 rods per minute and is just enough to power 2 nuclear power plants. And luckily it fits perfectly into a Mark II blueprint designer. So you can tile this later on when you scale up energy production. Oh, and one more thing, and this is really important. This process requires sulfuric acid, but also returns a little bit of it as well. So make sure you feed it back into the process through a VIP junction to keep the production from backing up. Now, I'm not gonna detail how to make every single element that goes into that, because that will take ages, especially for the later stages. How you bring your items to the power plant is totally up to you. I just run belts and pipes from my main factory, except for the uranium ore. I use a drone for that just to avoid the whole deadly radiation to my factory, which you can see how it can cause some issues. The belts I try to attach to the ceiling on stackable supports, but that's just my personal preference. Anyway you do it, you should be careful because by the end of the last stage we will be bringing in a ton of different items and it might end up looking like a spaghetti mess. And the drone is quite easy to set up actually. You just need a fully fueled port somewhere close to your blenders and the drone set up to bring uranium from a remote outpost. Since it's not that hard, I just run power towers towards that outpost so I don't have to deal with the other fuel logistic issues. If you have a modular factory, however, I guess the only option is to run a train to deliver all your materials to the power plant. For the nuclear plants, I use a tileable setup, where I place 2 of them in front of each other, receiving rods and eliminating waste in the same direction. Sadly, this tileable design doesn't fit in any blueprint designer, so to make things easier, I just blueprint the connection bit in the middle. It's not ideal, but it's something at least. Now, this is really important. The trick with placing them is not blocking yourself from expanding, and preferably you would want to build a plant far away from all the other factories, because it's going to give off a lot of radiation. So in a setup like this, we want to tile the uranium fuel in this direction and the power plants in this direction. So make sure you have plenty of room and you don't block them with each other. Oh, and don't worry about this setup for the moment. This will be required in the later stages of the plant. For now, we just put a container to stack our fuel and another one to store our waste. The one thing that I have not covered is water production, and we're gonna need a lot of it. If we're gonna build all 3 stages of fuel types, we're looking at powering about 18 nuclear power plants, so you can imagine the amount of water needed. The ratio here is 2 extractors for each plant, and since we're building 2 at a time, we will have 4 extractors for each pair of plants, delivering 480 cubic meters of water per minute, which is just below the Mark II pipe throughput. Now, 36 water extractors will take up a lot of space, and the plumbing delivering all that water will be incredibly difficult to build, so you need to make sure you plan it carefully. Here's my setup to do that. I place extractors in front of each other like this, and feed the water into a central pipe suspended on stackable supports. This setup allows me to expand my water production by continuing this line of extractors and stacking the next pipe on top of the first one. And in theory, I could expand like this until I reach the end of my water supply. But after placing 12 extractors in this configuration, you start needing pumps. So that's when you should start expanding horizontally rather than vertically. Notice how I don't combine water pipes. Fluids are a bit wonky, so I just don't want to deal with any flow issues at the moment, so I just use separate pipes for each pair of nuclear plants. But you don't need to worry about all that for now. To supply your 2 starting plants, you just need to bring your pipe above the plants and feed it into the splitter pipe. And congratulations, you just made your very first nuclear plant. You could stop here and just scale this up indefinitely, but the drawback of this setup is that it generates a lot of waste. You could just stack the waste in containers or load them into trucks and drive them off the map. But if you want to make something efficient and clean, you need to upgrade to plutonium. Using plutonium is one of the best ways to deal with radioactive waste. It consumes a large amount of uranium waste to produce a much smaller quantity of plutonium fuel, which is far denser and far more efficient. My setup can process the waste output of 10 uranium nuclear plants. That means once you upgrade to plutonium at that scale, you're effectively producing 0 uranium waste, while also unlocking 5 additional nuclear power plants for free. Those 5 extra plants will run exclusively on plutonium, which burns twice as long, so you will essentially be producing only a quarter of the waste compared to having 10 uranium plants. Now that's a great deal if you ask me. So let's break down how this actually works. We start with 2 blenders producing non-fissile uranium, which already takes care of a huge portion of our waste. That non-fissile uranium then goes into a particle accelerator to create plutonium pellets. Next, we split those pellets across 3 assemblers to produce encased plutonium cells. Finally, those cells are fed into 2 manufacturers, giving us 0.5 plutonium fuel rods per minute, just enough to power those 5 extra nuclear plants. The setup is actually quite simple. What is not simple, however, is bringing all the required items for this phase. Like I said before, you will most likely be producing all of these items in other places in your factory. All you have to do is produce a little excess and divert it to the power plant. To keep things clean, I just route every belt above the machines on the ceiling, like in the first stage. The tricky part is how you feed the rods into the plant. You want to be always consuming plutonium fuel rods, otherwise your production will eventually back up. I guess it'll take a long time for that to happen, and even once it happens, it'll unblock itself anyway, but it can still cause a bit of temporary inconvenience, so I suggest using a smart merger, prioritizing the plutonium rods input. Quick note here, the blenders do produce water as a byproduct that you need to deal with somehow. For me, it worked out great because I produced the nitric and sulfuric acid locally just for the power plant, and I use a VIP junction to feed it back into that production. And with that, the second phase of the nuclear power plant is completed. And you could stop there. You will most likely not need any more power to beat the game. But we're not happy with just stockpiling waste, are we? Of course not. And that brings us to the next phase, FICSONIUM. Producing FICSONIUM is definitely a challenge, mainly because of the endgame materials involved. The biggest bottlenecks are singularity cells, we need 5 per minute, and dark matter residue, which is usually created as a byproduct and can't be sunk or packaged. But the setup itself, it's actually simpler than plutonium. To make FICSONIUM, we need to belt all our plutonium waste along with singularity cells that we are making off-site to a particle accelerator. To convert all our plutonium waste that we created in the previous stage, we only need about 50% of the accelerator's capacity, so we can underclock it. Now the tricky part. Dark matter residue. We need 100 dark matter residue per minute, and to keep things simple, we'll be producing it locally in our nuclear plant. But we won't produce the full amount at this point, no, that would be too easy. We use a converter to make dark matter residue out of reanimated SAM, but we underclock it to 50% to produce half our requirement. Why? Because in our process, we will be creating some dark matter residue as a byproduct, and we want to make sure we consume that in order to not back up production. And to ensure just that, before we feed it into the accelerator, we run it through the low priority path of a VIP junction. Okay, now we take our 5 raw FICSONIUM per minute and dump it into a quantum encoder along with fixed trigons and excited photonic matter to finally make our FICSONIUM fuel rods. Luckily, the photonic matter is generated out of thin air inside the converter, so we just stuff that wherever we find space and underclock it to 25%. And that would be the end of it. However, like I mentioned before, producing FICSONIUM rods also generates dark matter residue as a byproduct. So to clear that out, we stick it back into the VIP junction leading to the particle accelerator, fulfilling our 100 units per minute required. Now we just run the rods to a container and plug it into the highest priority input of the priority merger that we talked about earlier. Again, we want to consume this fuel first, as backing it up will stop processing waste. And with that, we get to power an extra 2.5 nuclear plants for free. Before we wrap things up, here are a few key points you should remember from this build. 1. Use the 5 to 2 to 1 production ratio for uranium, plutonium and FICSONIUM. This setup lets you generate over 43,000 megawatts of power while producing 0 long-term waste. 2. Always prioritize higher tier fuel using priority mergers. Plutonium and FICSONIUM must be consumed first, or your waste processing will eventually back up. 3. Byproducts are the real bottleneck here. Water, sulfuric acid and dark matter residue will stop your production if they're not handled properly. Use VIP junctions and feedback loops to keep everything flowing. 4. Build near massive water supply. You'll need up to 36 water extractors, and trust me, moving that much water is not something you want to do over long distances. And 5. Be patient. Nuclear fuel is a low-volume, high-power system. It can take a while for manifolds to fill up and for everything to stabilize, but once it does, you're set for the rest of the game. And that's it, my multi-stage plan for a 100% clean, zero-waste nuclear power plant. Is it worth it? You tell me in the comment section below. See you next time for more satisfactory tips.